In the last section, we created a new file that we're going to use to benchmark the pbkdf2 function. And we're going to eventually use this to detect whether or not Node truly is single-threaded. Now we've got our function call inside of here. So the next thing we need to do is add a little bit of code to benchmark how long this thing takes to run. To benchmark it, I'm going to first declare a new variable outside of the function call. I'm going to declare a new variable called start, and this is going to record the time at which we start our call to the pbkdf2 function. So I'm going to say start equals date.now, like so. Then inside the callback, I'm going to add a console log, and this thing is going to log out exactly how long it took from recording the start time to getting inside the console log. So I'll say console.log. I'm going to pass in a string with 1, like so, because we're going to eventually have multiple console logs inside this program. And by adding in the little 1 right here, I'll know which console log we are seeing inside of our terminal. And then as a second argument, I'll take the new time, so like the current time, with date.now, and then I'll subtract start from it like so. So we take the start time, we call the function, and then when the callback is triggered, we take the new current time, we subtract the old time, and we should get out how long it took in milliseconds to print out or to calculate this hash value. So let's save this file. We'll go run this at the terminal, and we'll see how long it takes to calculate a hash. So back in my terminal, I'm going to make sure I'm inside of my directory with the threads file, and then I'll run node threads.js, like so. And when I do so, you'll see that I print out 1 colon and then 1073. So that means it took 1000 milliseconds, or just about 1 second, to run that pbkdf2 function. Okay, that's a good benchmark. We now know how long it takes to calculate exactly 1. I'm now going to go back to my code editor, and I'm going to take this entire function call right here, and I'm going to duplicate it down underneath. So I'm going to copy it, and then on the next line down, I'll paste it, and I'll make sure that I update the console log right here to 2 as well. Now before we run this back at the terminal, I want to make 2 things extraordinarily clear here. Okay, 2 things that are absolutely critical to understand about the code we've written inside this file. First off, when we run this file, both functions, both this call and this call, are going to be invoked at more or less the exact same time. So this code is not going to wait for the first call to finish up and get to this console log before starting the second one. That's not what's happening. The instant we execute this file, they are both executed at the same exact time. Now the second thing to be aware of here is that we are not modifying the start variable at all. So each console log that we're going to eventually see, like console log 1 and console log 2 right here, are going to be the exact amount of time that it took from starting our program to the time that it took for each function call to end. So with that in mind, let's go back to the terminal, and we're going to run this file again and see what happens. Okay, so back at the terminal, I'll run node threads.js. Now, when I run this, you're going to notice that my time is slightly above what it was before. So originally I got about 1073, and now I'm getting 1150 and 1159. But chances are you are seeing 2 times that are very, very close to your original time. Chances are. It might not be the case, but chances are you're going to see 2 times that are very close to the original ones. The reason that my 2 times right here are a little bit above or a little bit elevated is just because I'm running some screen recording software right now that uses up a lot of CPU on my computer. But anyways, the point is that chances are we're going to see 2 times or 2 benchmarks that are extremely close in time to the original one. Now, just to make sure that you really understand what's going on here, I want to show you a couple of diagrams that are going to help you understand the significance of this result right here, okay? All right, so a couple diagrams. Here we go. All right, so first off, we got this diagram. So this is a diagram of what I would have expected to see if Node was truly single-threaded. Remember that a thread presents a linear series of instructions to our CPU. So the CPU has to follow them all in order of the order that we present them in. Now we know that one call to pbkdf2 takes exactly 1 second. So like 1 second right here. So with 2 function calls, if this really was a single-threaded system, I would have expected this entire process to take 2 seconds total. We get 1 second for the first call. That completes. We should see a console log. And then after 1 additional second, we should see a second console log appear. Let's take a look at a diagram that's going to make this expectation right here much more clear. And again, this is talking as though we are assuming that Node is single-threaded, and it's not quite. Okay, so second diagram, just to clarify what we would expect if Node really was single-threaded. So I would have expected that we would have started our program at time of 0 seconds right here. The first call to PBKDF2 would have taken 1 second, and then as soon as that was complete, we would then start up the second call, and then at 2 seconds, the second call would be complete as well. However, both these diagrams that I just showed you clearly was not what occurred. This is not what actually happened when we ran our code. We very clearly saw that both these logs occurred at basically the same time, and it took just about equal to the original run of our threads function, where we were only doing 1 single hash. So let's take a look at a diagram of what really happened. So here's the reality. The reality was that we started up our program at 0 seconds up here, and then it took exactly 1 second for both of those function calls to get to the callback. So clearly, this is indicating that something is happening to indicate that we are breaking out of a single thread setup with Node. Because if we only had 1 single thread, we would have seen the first function call complete and then the second one start up. So let's pause right here, and we're going to start to investigate why this is happening in the next section.